Hello, I welcome you all to this another interesting screencast. The problem reads the box slides down the slope described by the equation y is equal to 0.05 x squared meters, where x is in meters. If the box has x components of velocity and acceleration of vx equal to minus 3 meters per second and ax equal to minus 1.5 meters per second squared and x equal to 5 meters, determine the y components of the velocity and the acceleration of the box at this instant. This problem is coming from the Mechanics of Materials textbook, 14th, not Mechanics of Materials, Dynamics, Engineering Mechanics textbook, 14th edition, Dynamics, Engineering Mechanics textbook, 14th edition by R.C. Benam. So we have a box here that slides down the slope described by the equation y equal to 0.05x squared. And they've given us the velocity and the acceleration at x equal to 5, and we have been asked to determine the y components of the velocity and the acceleration of the box at this instant. So let me just describe the notations that we're going to be using. So y prime will mean dy dx. X dot will mean dx dt. X double dot will mean dx double differentiating twice with respect to time. Okay, so here we've been given, we do have the equation that governs the slope and is equal to 0.05 x squared. Therefore, y prime will just be equal to dy dx, which just gives us a 0.1 x. Okay, and then we do have x dot, and our x dot here is just equal to v sub x, and is given as minus 3 meters per second. And we also have x double dot, which is a sub x, which is the acceleration, and is given as 1.5 meters per second. And these were measured at x equal to 5. And everything else will be computed at that 5 meters. Okay, so let's go ahead. So we want to find y double dot, which is just a dy dt. So to find this, we are going to use the chain rule. We use the chain rule. So we are going to say dy dx, okay, by dx dt. Okay, so this is just y prime by x dot, and we do have these values. We can just replace them in. Y prime we said is 0.1x, and x dot we said is given as minus 3. Okay, therefore y dot at x equal to 5, if we are to work out that, just gives us as 0.1 by 5 by minus 3. This is just going to be equal to minus 1.5 meters per second. So we have found the velocity, the y component of the velocity. Let's go to the y component of the acceleration. So this y component of the velocity is the one that we're going to use to calculate the acceleration, right? We know that, right? Because velocity is related to acceleration. Displacement, you can relate displacement to velocity, velocity to acceleration, right? So let's now rewrite the function that defines our velocity, and that function is with respect to time. So y dot is equal to 0.1x, okay, x dot. We are getting it here. All right. Remember that? So this is the function that governs our velocity. Okay. And when we look at this particular velocity function, it has two variables, and both of them are functions of time. So let's say we have u equal to 0.1x, and I'll use another variable w equal to x dot. And we are saying both these variables are functions of time. So since they are being expressed as a product in this particular case, then we can use the product rule, right, to simplify them. I mean, to work it out when we want to find the derivative of our velocity with respect to time. Okay. So let's go ahead. So we are going to say our y double prime, okay, is just going to be equal to, so let me just write what this means. If we are to work out this, so d du w, this is going to be equal to, we can say w du plus, okay, this is the product rule. This is what we intend to do. Okay, w du plus u dw. All right, this is what we intend to do. So y double dot is just going to be equal to, w is x dot, which is w, there we go, and then du, so we are finding the derivative of this 0.1 x with respect to t, so it will just become what? 0.1 x dot, right? Agree? So we've done the first part. Then we'll say plus u. What is our u? Our u is just 0.1 x. Okay, what is dw? dw, derivative of x dot with respect to t, just becomes what? X double dot. Is that fine? Great. And we know these values already. X double dot, x dot, we said is equal to minus 3 meters per second squared, and x double dot is just equal to minus 1.5 meters per second. Therefore, y double dot at x equal to 5, because we are finding all this at x equal to 5, we just plug in this equation, we plug everything in there. Okay, so let's do so. We plug everything in there. So what do we get? X dot is minus 3, okay, and then 0.1 by x dot again, which is minus 3, okay, plus 0.1 by 5, and then x double dot is minus 1.5. So this therefore gives me a 0.15 meters per second squared. Right, so we have found the answers, the solutions. We have velocity there, y component of velocity, okay, and then we have also the component of our acceleration, the y component of our acceleration. Okay, I think this is really about it. And I hope this particular video was helpful. And if it was, give me a thumbs up. Like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.